Good day, everybody. How are you all doing? For those of you who do not know me, this is Dr. Nandi. I frequently go live on my channel and discuss math problems, all kinds of math problems, stat problem, algebra problem, geometry problem. I also have lots of YouTube videos which I have recorded and solved math problems. So when you get a chance, please take a look at these videos in my channel, and please subscribe to my channel by hitting the red subscribe button. If you like those videos, please give me thumbs up. That it means a lot to me. It really motivates me. And let me know where you are watching from. What time is it? Around this time. Right now here, this is afternoon, bright and beautiful sun outside, and today we are going to talk about an interesting situation. We are going to talk about the probability distribution of sample proportion of success, aka known as sampling distribution. Sampling distribution. So let's get started. So we are going to talk about probability distribution of this thing is called read as P hat. It is the sample proportion of success. Sample, because focus on the word sample proportion of success. Okay. Because this data is coming from sample proportion, sample data, it is also called the sampling distribution of P hat. Distribution of P hat. Okay. So we are going to do an experiment. We take a fair coin. Take a fair coin. Fair coin means it's same weight on the head side and on the tail side. Bottom line, there is no preference from the beginning on which side it land face up. It might be tail face up, it might be head face up. Why, you ask me? Because it's a fair coin. Equal weight on both sides. Take a fair coin and toss it 3 times. The first time you toss the coin, possibilities or outcomes, possibilities or number of outcomes or results. Number of outcomes means results. When you toss the same coin 3 times, the first time you toss it, it can be 2, either a head or a tail. Next time you are tossing the coin, it might be head or tail, 2 possibilities. And the last time or the final time or the third time you toss the coin, there are 2 possibilities. So why are we multiplying this? Because these are independent events. And what happens in the first toss will not influence what happened in the second toss, what happened in the first toss. Or what happens in the third toss will not be influenced by what happened in second toss and in the first toss. So total number of outcomes, 2 comes from the fact that each time you toss the coin, there are 2 possible outcomes, either a head face up or a tail face up. Why do you multiply it by 3? Because there are 3 tosses. So total number of possibilities are 8. When you toss a coin, fair coin, 3 times. Okay. So what are the possible outcomes? Let's make a listing of those possible outcomes. Okay. You can get head, head and head. Let's count the number of heads in each possibilities. Number of heads in this case is 3. Okay. The next can be head, head and tail. Number of heads in this possibility is 2. Next, it can be head, tail, tail. Number of heads is 1. Or it could be tail, tail, tail. All 3 lands on tail face up. 0 number of heads. Okay. The next one can be tail, head and tail. Number of heads is 1. Okay. Then it can be tail, head and head. Number of heads is 2. Or it could be tail, tail and head. In this case, number of heads is 1. Or it could be H, T, H. Number of heads is 2. Okay. Now we are going to look at the sample proportion of heads. Sample proportion of heads. Proportion of heads. In 3 tosses. This is nothing but P hat. Okay. So in this one we have 3 out of 3 tosses. So sample proportion is 1. This one we have 2 out of 3 tosses is 0.667. This one we have 1 out of 3 is 0.333. Next one is 0, 0 out of 3. Next one is 1 out of 3, as you noted before, is 0.333. So this is sample proportion of success or sample proportion of heads. This one is 0.667. This one is 0.333. And this one is 0.667. Okay. So as you know, there are 8 possible outcomes and they are equally likely. So probability of each possible outcome. This one is 1 out of 8. Why did you say 8? Because there are 8 possibilities and this is only one of the 8 possibilities. We are assuming every of these outcomes or results have equal probability of happening. So this is 0.125. Next one is also 0.125. Next one is 0.125. Next one is 0.125. Again 1 out of 8. Not 0. It's 1 out of 8. Again this one is 0.125. This one is 0.125. This one is 0.125 and this one is 0.125. Okay. So now we can make a list of P hat. P hat, you remember, is a sample proportion of success. Proportion of success. And we can sample proportion of success and the corresponding probability. Corresponding probability of each outcome. Okay. So this is basically a probability distribution. So the first possibility, we will start from the low and move on to the high, 0. And how many times 0 appears in this list? Only once, and its probability is 0.125. Because there are 3 1s and 3 2s, we are going to combine them and put it in over here. So 1 has a probability of 0.333, okay, and it is 1 out of 3, okay, and that appears 3 times, okay. 1 out of 3 appears 3 times, okay. So it is 0.333 is a sample proportion of success. When 1 head appears in 3 tosses, 1 out of 3.333, and that can happen 3 times. So, and its probability is 0.125 multiplied by 3, which is 0.375. Okay. Similarly, 2 out of 3, that is 0.667, and that also happens 3 times, here, here and here. So it is probability same 0.125 for each multiplied by 3 is 0.375. Okay, and the last value of the sample proportion of success is 1, and that happens only one time, is 0.125. Now we will use our TI-84 calculator to calculate the mean of this probability distribution and its standard deviation. So first thing we will do is to clear the memories of the calculator. So we will press second button, then the plus button on the bottom right, then number 4, we will get clear all list on our calculator and hit enter. Done. We cleared the memories of the calculator. So that means clear memory. Clear memory. Okay. Now we will press stat button again and then number 1, which is edit. Enter P hat, sample proportion of success in L1, and probability, corresponding probability in L2, corresponding probability in L2, probability in L2. Okay, so let's do that. So as I said, the first step is to clear the memories of the calculator. So on second button, plus button on the bottom right, then number 4, get clear all list on your calculator screen, hit enter, done. Then stat button and 1. In L1, I'm going to enter the p-hat value, which are 0. Next one is 0.333. Next one is 0.667. And next one is 1. After I'm done with entering the 4 numbers in L1, 4 values of p hat, I press the right cursor key to move the cursor to the first line in L2, where I enter the corresponding probability. So this is the corresponding probability that will go in L2. The sample proportion values will go in L1. Okay. So in L2, the first value is 0.125. Next value is 0.375. And next value is also 0.375. And the last value is 0.125. Okay. Again, p hat values in L1, corresponding probability values in L2. Okay. Now we are ready to calculate the mean and the standard deviation. Stat, then highlight calc on the top row. That means move the cursor to calc on the top row. Then select number 1, which is one where stats. So I press the stat button, then the highlight calc on the top row. Then number 1 is one where stats. My list first line should be always sitting on L1. Second line is frequency list. Remember, I have entered the probability or relative frequency in L2. So I have to make this L2. How do I do that? Second button and then 2. Second and 2 makes it L2. So frequency list, second and 2 is L2. And then I go down on calculate and hit enter. Okay. So my mean x bar, that is my mean, is equal to mu, because the population is 0.5. Okay, and my sigma x standard deviation of this distribution, standard deviation is sigma x is given as 0.288 and 8. Okay, let's make a note of this too. Now I will show you where does mu, the mean, comes from. So this is the sampling. So this is the sampling distribution, because I have a list of the sample probabilities and the corresponding probabilities. So sampling distribution of p hat. Okay, notice mu p hat, which is the mean of the sampling distribution came out as 0.5, which is, if you think about it, is small p, which is the probability of success. That is, in this case, probability of getting ahead in the long run, of success. Or in other words, you can write mu p hat is equal to p, sample population probability of success. I should mention clearly, this is the population probability of success, because there is no hat on this, and this is the probability of getting ahead in the long run is 0.5. Now what is sigma p? Sigma x came out as this. What really is sigma x? Okay, now this is kind of binomial distribution. So binomial distribution is for a binomial distribution, if you remember, variance is given by variance, which is sigma square of standard deviation, is n times p times 1 minus p. So in this case, I toss the coin 3 times. My probability of success is 0.5 times 1 minus p is also 0.5. So that is equal to 0.75. That's your sigma square. So how, now let's take the sigma square, variance, sigma square, and divide it by sigma square is, let's keep it like this, okay. So standard deviation would be square root of sigma square for a binomial distribution. Deviation will be equal to square root of sigma square. Okay. So we can write it as square root of n let's leave it like this, okay. Okay. Now the standard deviation of the sampling distribution of p hat, standard deviation of sampling distribution of p hat, which came out as point, what was it? 0.288. What is the formula behind it? Sampling distribution is is equal to is equal to square root of p times 1 minus p divided by n. Is it really true? Let's calculate it out. So sigma, standard deviation of the sampling distribution, is given as this. So sigma p hat would be, this is sigma p hat, standard deviation of this distribution is, we got the value, but how is the value related to the population proportion of success? Let's calculate 0.5. 1 minus 0.5 is also 0.5, divided by number of times we are tossing the coin is 3. Let's see what it is. So 0.5. So let's do the square root first. So how do you do the square root first? Second button and excess square gives you the square root. Inside the square root, 0.5 multiplied by 0.5 divided by number of times you are tossing the coins, sample size is 3. And it will work out the same number, 0.28875. Okay, so what is the bottom line? Bottom line is mu p hat, the mean of the sampling distribution, is equal to population proportion of success, and sigma p hat, which is the standard deviation of the sampling distribution of p hat, is square root of p times 1 minus p divided by n. Okay. Okay. And for binomial distribution, standard deviation is square root of sigma square, which is n times p times 1 minus p, and that would be square root of, so we are taking second x square, get the square root, 0.75 inside the square root is 0.866 in this case. How is that related to the binomial, to the sampling distribution of p hat? We can show that that sigma p hat, I should not write here on this side, I should write here sigma p hat. It can be shown, which I will not show here. Sigma p hat is equal to binomial standard deviation divided by n square. Okay, divided by n square. Okay, so let's forget about it. These are the two formulas. So what we got as standard deviation, sigma x bar is equal to 0.2888 for the sampling distribution of p hat, that is actually equal to square root of population proportion of success times 1 minus p divided by n. And I showed you by plugging in p is equal to 0.5, 1 minus p is also 0.5 divided by n. N is sample, how many sample size, which is 3. This is n over here, divided by n. Okay. So these two things to remember. Mu p hat, the center of the sampling distribution of p hat, is population proportion of success, and standard deviation is square root of population proportion of success times 1 minus p divided by n. So how does the sampling distribution of p hat looks like? Well, it is a bell-shaped distribution like this. And the center, so we have p hat values on the horizontal axis, and of course probability on the vertical axis. So center where the peak is the highest, that value is known as mu p hat is equal to p. And we already showed sigma p hat is equal to square root of p times 1 minus p divided by n. Okay. So bottom line, sampling distribution of P hat is bell-shaped. Sampling distribution of P hat. Okay. Why sampling? Because we get the P hat values by sample. Okay. So I will sign off today here. If you have any question, any doubt, do not hesitate to write me a note. I'll get back to you as soon as I hear from you. I will answer each and every one of your question. So please do not hesitate. Just go ahead and shoot me a question. I'll try to answer to the best of my ability. Again, thank you for taking the time to watch my video. If you like this video, share with your friends. And if you like the videos in my channel, please subscribe to it by hitting the red subscribe button. And please do not forget to watch me tomorrow. When you subscribe to my channel, please click on the notify button. Also, it will notify you every time I upload a new video. And when you subscribe to my channel, please drop a comment where you are watching from, what is the time of the day where you are watching from. I would really love to know that. And again, thanks for taking the time to watch my video. Have a great rest of your day. I will see you tomorrow. Take care. Have a nice day.